We'll start in 1 minute. Today we're going to cover section 9.8 on solving quadratic inequalities. One thing about doing this is we can combine what we already know. We know how to solve certain inequalities, and we've also learned how to solve quadratic equations. So putting those two together will enable us to solve quadratic inequalities. At about 8:40 a.m. today, we'll have quiz 9. And I'll email that to you at about that time. So let's go ahead and start section 9.8. Keep in mind that test 4 is next Friday, 1 week from today. The test 4 review videos are available on YouTube. And part of next week we'll be able to review for test 4. Okay, solve each quadratic inequality, write solutions in interval and algebraic notation. Okay, to solve a quadratic inequality, we want to find endpoints of the intervals. The endpoints divide the entire number line into separate intervals. So the endpoints are the solutions to the quadratic equation that's in standard form. So for this first example, I'll write out a little bit of detail. Endpoints are the solutions, in this example, to the quadratic equation 2x to the second minus 7x plus 3 equals 0. So we know how to solve quadratic equations. Let's use the quadratic formula. So just as a reminder, the quadratic formula is x equals negative b plus and minus the square root of b to the second minus 4ac, all divided by 2 times a. Okay, so for this inequality, for this quadratic equation, a is 2, b is negative 7, and c is positive 3. Okay, so we'll solve that using the quadratic formula. Negative b is the negative of negative 7, and then plus and minus the square root of the number negative 7 squared minus 4 times 2 times 3. And this is all divided by 2 times 2. Okay, up here we'll continue. The negative of negative 7 is 7, and then plus and minus the square root of some number, all divided by 4. Okay, so inside the square root, the number negative 7 squared is 49, and we're subtracting 4 times 2 times 3, which is 24. So we're subtracting 24. And this is going to work out pretty nicely for us because 49 minus 24 is 25. So the square root of 25. And 25 is a perfect square. The square root of 25 is 5. So the two solutions are 7 plus and minus 5 divided by 4. So we want to know each of the solutions separately. So one solution is 7 minus 5 divided by 4. 7 minus 5 is 2. 2 divided by 4 is 1/2. So 1/2 is one of the solutions. And then the other solution, 7 plus 5 divided by 4. 7 plus 5 is 12. 12 divided by 4 is 3. So we get x equals 3 for the other solution. Okay, these are the two endpoints, and those two numbers divide the number line into 3 separate intervals. And you might remember from earlier this semester how to solve inequalities. We pick a test point from each of the 3 intervals, and then we replace every x in the inequality with our test point, and then determine if the inequality is true or false. Okay, in this first interval on the left, from negative infinity up to 1/2, we can pick x to be 0. And then in the inequality, replace every x with 0. We're just left with 3 greater than or equal to 0. And that is true. So that means every number from negative infinity to 1/2 is part of the solution set. Okay, then in the second interval, pick any number you want between 1/2 and 3. So I'll pick x to be 1. And 1 is a nice number to pick because when you replace x with 1, for example, this one, 2 times 1 squared is just 2, and minus 7 times 1. So 2 minus 7 is -5. -5 plus 3 is -2. And so we get -2 greater than or equal to 0, but that's false. So none of the numbers between 1/2 and 3 are solutions. And then in the third interval, pick any number you want that's greater than 3. So I'll pick x to be 4. Okay, then in the inequality, when I replace this x with 4, 4 squared is 16. 2 times 16 is 32, so I'll write 32. And then minus 7 times 4 is minus 28. And then plus 3 greater than or equal to 0. 32 minus 28 is 4. 4 plus 3 is 7. 7 greater than or equal to 0 is true. Okay, so all of the numbers from 3 to infinity are solutions. Okay, the next question, do we include the endpoints? Well, in this case, we include both endpoints. Remember that both 1/2 and 3, those are the solutions to this equation, 2x squared minus 7x plus 3 equals 0. So if we were to replace x with 1/2 in this inequality, we would get 0 greater than or equal to 0. And that is true. It's the or equal to 0 that makes it true. So we definitely include 1/2. And for the same reason, we're going to include 3, because replace every x with 3, we also get 0 greater than or equal to 0, which is true. So put a bracket at 1/2 and shade to the left. Put a bracket at 3 and shade to the right. So this is the graph of the solution set. I ran out of room, so I'm going to write at the top of the page the interval notation. So you can still see the graph. So this part of the number line from -infinity up to 1/2, including 1/2, in interval notation, that's parenthesis -infinity, comma, 1/2 bracket. And then we use the union symbol. And then this part of the number line from 3 to infinity, including 3, we put a bracket 3, comma, infinity. Okay, so this is the interval notation for the solution. And then the algebraic notation, the interval on the left from -infinity to 1/2, including 1/2, that is x less than or equal to 1/2. Then we use the word or in the algebraic notation. And this part of the number line from 3 to infinity, including 3, this is x greater than or equal to 3. Okay, so this is the complete algebraic notation. Okay, so nothing has changed about interval notation. It's the same as what we've seen before, and the same is true with the algebraic notation. Okay, we'll move on to the next example. So the idea is the same. This is a quadratic inequality. Well, we do want, we want to put it in standard form. So we'll subtract 3 from both sides so that the right-hand side is 0. So 3y to the second plus 8y minus 3 is less than or equal to 0. Okay, to find the endpoints, I won't use all the words I did last time, but solve the equation 3y squared plus 8y minus 3 equals 0. The solutions to this equation are the endpoints of the intervals. Okay, so A is 3, B is 8, and C is -3. So this time the variable is y, so y equals -b, which is -8 in this case, plus and minus the square root of 8 to the second minus 4 times 3 times -3, all divided by 2 times 3. Okay, so y equals -8 plus and minus the square root of a number divided by 2 times 3, or 6. Okay, so inside the square root, 8 to the second is 64. And we're subtracting 4 times 3 times -3. So it's 64 minus -36. But that is the same as adding 36. Okay, so things are working out really nicely so far. Y equals -8 plus and minus the square root of 100. 100 is a perfect square. Okay, the square root of 100 is 10, so y equals -8 plus and minus 10 divided by 6. Okay, so up here we'll write the solutions separately. since we need to know the separate solutions. So one is -8 minus 10 divided by 6. So -8 minus 10 is -18, and -18 divided by 6 is -3. The other solution is -8 plus 10 divided by 6. So in the numerator, -8 plus 10 is 2, and 2 divided by 6 simplifies to 1/3. So the other solution is y equals 1/3. Okay, so those are the two endpoints of the intervals. Those two numbers divide the number line into 3 separate intervals. So now we do what we did in the previous example. We just pick test points from each of the intervals. So in the first interval, we can pick any number we want less than -3. So I'll pick y equals -4. Okay, this time the arithmetic will be a little more involved, but not too bad. So you can use either of the two inequalities. It doesn't matter because they're equivalent when you're testing your test points. So maybe I'll just use the one on the original inequality. So we get 3 times the number -4 squared. The number -4 squared is 16, so it's 3 times 16. And then plus 8 times -4, which is -32, less than or equal to 3. 3 times 16 is 48. And if we add -32, that's equivalent to subtracting 32. And then finally, 16 less than or equal to 3. Okay, so that's false. So no, none of the numbers from -infinity to -3 are solutions. Okay, in the second interval, 0 is in this one, so picking y to be 0 will be pretty convenient. So in the original inequality, replace every y with 0, we get 0 less than or equal to 3. And that is true. So all of the numbers between -3 and 1/3 are solutions. Okay, in the third interval, we can pick any number we want that's greater than 1/3. 1 is in that interval, so 1 is usually a nice number to use as a test point. So in the inequality, replace y with 1. So 3 times 1 squared is just 3, plus 8 times 1. So we have 3 plus 8, which is 11, and 11 less than or equal to 3 is false. So none of the numbers from 1/3 to infinity are solutions. Only the numbers between -3 and 1/3 are solutions, including the endpoints. Each of the two endpoints is what makes the left-hand side of the inequality in standard form 0. And 0 less than or equal to 0 is true. It's the or equal to 0 that makes it true. So we're including the endpoints. So graphically, we put a bracket at -3 and a bracket at 1/3, and then shade in the interval in between. The interval notation for this solution is bracket -3 comma 1/3 bracket. That's the interval notation. The algebraic notation, if y is between -3 and 1/3, including -3 and 1/3, we write it as -3 is less than or equal to y, which is less than or equal to 1/3. Okay, both of these are pretty nice examples because the endpoints were not really that hard to handle. Ordinary fractions and integers. Okay, but we'll encounter situations that are a little more involved than that. Okay, so let's try this one. Solve y to the second minus 4y plus 20 is less than 0. Okay, so the endpoints, we want to find the endpoints by solving a quadratic equation. So we want to solve y squared minus 4y plus 20 equals 0. Okay, we can use the quadratic formula. So in this case, a is 1, b is -4, and c is 20. So I'll go ahead and write that down. A is 1, b is -4, c is 20. Okay, so y equals the negative of -4 plus and minus the square root of the number -4 squared minus 4 times 1 times 20, all divided by 2 times 1. Okay, then we'll do the arithmetic. The negative of -4 is 4, plus and minus the square root of some number, all divided by 2. Okay, so inside the square root, the number -4 squared is positive 16, and we're subtracting 4 times 1 times 20, we're subtracting 80. Okay, so y equals 4 plus and minus the square root of -64. We know how to simplify this further, but when solving quadratic inequalities, we've done enough. The two solutions are non-real numbers, so that means there are no endpoints to divide the number line into separate intervals. But we still have an interval to test. It's just the entire number line. The solutions are non-real, so there aren't any real numbers to divide the real number line into separate intervals. So all we have to do is pick a number, any number you want, between -infinity and positive infinity as a test point, and then replace y with the test point and determine if the resulting inequality is true or false. Okay, so there's only one interval to test. I'll just pick y to be 0. That's usually the most convenient choice for a test point. And then in the inequality, replace every y with 0. We're just left with 20 is less than 0. We know that that's false. So there's no solution to that one. That's our conclusion, no solution. If you encounter this in Newton, then you'll select the empty set, the set that has nothing in it, for the solution. Okay, I'll just mention if this inequality had been greater than 0 instead of less than 0, then it would would have been all real numbers. So if this had been greater than 0, then the interval notation for the solution would be negative infinity to positive infinity. Okay, let's jump to the next one. Okay, solve this inequality. X squared plus 10x minus 9 is greater than 2. We want one side to be 0, so we'll subtract 2 from both sides. And we get x squared plus 10x minus 11 is greater than 0. So we want to find the endpoints by solving the equation x squared plus 10x minus 11 equals 0. We can solve this equation by factoring. So one of the factors is x plus 11, and the other factor is x minus 1. And you can easily verify that those factors are correct. Since we started out with a trinomial with leading coefficient 1, all we have to do to check is that positive 11 times negative 1 is equal to negative 11. And positive 11 plus negative 1 is positive 10. Okay, so the two endpoints are negative 11 and positive 1. So on the number line, we put the two endpoints. Those two numbers divide the number line into separate intervals. So in the first interval, we can pick any number we want that's less than negative 11. So I'll pick x to be negative 12. Okay, on this one, I'll show you an alternative. You don't have to do it this way, but we can write the inequality where the left-hand side is in factored form. So in other words, x plus 11 times x minus 1. The inequality is greater than 0. So this is what we would get if we just factored the left-hand side of this inequality directly. The right-hand side is greater than 0. So if you want to use the factored form, it can be a little more convenient. If our test point is x equals negative 12, then for the factor on the left, just replace x with negative 12. Negative 12 plus 11 is negative 1. And then negative 12 minus 1 is negative 13. And the inequality is greater than 0. And negative 1 times negative 13 is 13. 13 is greater than 0. That's true. So yes, all of the numbers from negative infinity up to negative 11 are solutions. If you would rather use the test point that's not in factored form, then you can still make it work. In the middle interval, we can pick x to be 0. Okay, and when you pick x to be 0, it's still pretty easy using the factored form, but the non-factored form is also pretty easy when the test point is 0. So if I use this inequality, replace every x with 0, I get negative 11 is greater than 0. That's false. So none of the numbers from negative 11 to 1 are solutions. And then finally, in the third interval, let's pick x to be 2. Okay, so we have multiple options. This time I'll use the original inequality, not because it's the easiest thing to do, but just to show you that it can be done. So when x is 2, replace every x with 2. So 2 squared is 4, and then plus 10 times 2 is plus 20, and then minus 9 greater than 2. 4 plus 20 is 24. 24 minus 9 is 15. And 15 greater than 2 is true. So yes, the numbers from 1 to infinity are solutions. Okay, what about the endpoints? The endpoints in this inequality, when we made one side 0, the endpoints are what make the left-hand side 0, but the inequality 0 greater than 0 is false. So that means the endpoints are excluded this time. So whenever it's a strict inequality, like greater than or just less than, the endpoints are always excluded in those cases. Okay, so graphically we put a parenthesis at negative 11 and shade to the left, put a parenthesis at 2 and shade to the right. And then the interval notation for this part of the number line on the left, the interval notation of the solution is parenthesis negative infinity, comma, negative 11, parenthesis, and then union, parenthesis 1, comma, infinity. This is the interval notation. The algebraic notation, this part of the number line is x is less than negative 11. Then we write the word or. This part of the number line is x is greater than 1. Okay, I'll do one more example, and then we can stop to take the quiz. Okay, this example down here on the bottom, the second example on this page. So this time we have x plus 2 times x plus 6 greater than or equal to 21. So what we should do on this one, multiply the two binomials. So we get x squared plus 6x plus 2x plus 12 greater than or equal to 21. And then combine like terms, x squared plus 8x plus 12 is greater than or equal to 21. And then subtract 21 from both sides. So we get x squared plus 8x minus 9 is greater than or equal to 0. Okay, then we find the endpoints. So in this one, just be aware that sometimes you have to do some preliminary work before you can identify the endpoints. So the endpoints are the solutions to x squared plus 8x minus 9 equals 0. So on this one, we can solve this equation by factoring. One factor is x plus 9, the other one is x minus 1. So since the coefficient of the trinomial is 1, you can verify easily. 9 times negative 1 is negative 9. Positive 9 plus negative 1 is positive 8. Okay, so this has two solutions, x equals negative 9 and x equals positive 1. So this is kind of like the one we just did. We have integers for endpoints. 3 intervals to test. So on the left, pick any number you want that's less than -9. So I'll pick -10. And let's use the original inequality. That looks like it's going to work out pretty nicely. If you replace this x with -10, -10 plus 2 is -8. Replace this x with -10, -10 plus 6 is -4. And -8 times -4 is 32, and 32 greater than or equal to 21 is true. So all of the numbers from -infinity to -9 are solutions. Okay, then in the middle interval, pick 0 again. So for this one, I'll just use this inequality. Any inequality will work, but this one, when x is 0, this one might be the most convenient. Replace every x with 0, we get -9 is greater than or equal to 0, but that's false. So none of the numbers between -9 and 1 are solutions. And then in the third interval, pick any number you want greater than 1, like x equals 2. So on this one, I'll use the factored form again. Replace x with 2. 2 plus 2 is 4. And 2 plus 6 is 8. And 32 greater than or equal to 21 is true. So yes, all of the numbers greater than 1 are solutions. And since the inequality is greater than or equal, we include both endpoints. And the interval notation, parenthesis -infinity, comma, -9, bracket, and then union, bracket, 1, comma, infinity. That's the interval notation. And then the algebraic notation, x is less than or equal to -9, or x is greater than or equal to 1. Okay, we'll stop there and I'll go to my office and send you the quiz. So join the Zoom meeting. I'll be there shortly. We'll start in a few seconds. Okay, today we'll cover section 9.8 on solving quadratic inequalities. We know about solving some inequalities, and we also know some things about solving quadratic equations. So putting both of those things together will enable us to solve quadratic inequalities. Remember, there's a quiz today at 9:40, and so at about that time I'll go to my office and send you the quiz, and then you can join the Zoom meeting. Keep in mind that next Friday, 1 week from today, is test 4. And there are some test 4 review sheets that are videos that are on YouTube that you can start looking at if you want. Okay, so let's start section 9.8. We'll discuss how to solve quadratic inequalities. And then we'll write the solutions in both interval and algebraic notation. Okay, so generally we want 0 on one side of the inequality. And then we want to find the endpoints that divide the number line into separate intervals. So we find the endpoints by solving a quadratic equation that's in standard form. So for this particular quadratic inequality, we're going to find the endpoints by solving the quadratic equation. Find the endpoints by solving 2x squared minus 7x plus 3 equals 0. If the solutions are real numbers, then those real numbers will divide the number line into separate intervals. Okay, so we can use the quadratic formula. It turns out that you could solve this one by factoring, but let's practice the quadratic formula. I'll write down the quadratic formula. X equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2 times a. And for this quadratic equation, a is 2, b is negative 7, and c is positive 3. Okay, so x equals the negative of negative 7 plus and minus the square root of the number negative 7 squared minus 4 times 2 times 3, all divided by 2 times 2. And then arithmetic, the negative of negative 7 is positive 7, plus and minus the square root of some number, all divided by 2 times 2, which is 4. Okay, inside the square root, negative 7 squared is 49, and we're subtracting 4 times 2 times 3, which means we're subtracting 24. 49 minus 24 is just 25, and the square root of 25 will simplify to 5. So up here I'll just write x equals 7 plus and minus 5 divided by 4. We want to know the individual solutions because those two different solutions are the endpoints of the real numbers. So one solution is 7 minus 5 divided by 4. 7 minus 5 is 2. 2 divided by 4 is 1/2. So 1/2 is one of the endpoints. The other endpoint is 7 plus 5 divided by 4. 7 plus 5 is 12. 12 divided by 4 is 3. Okay, so we use those two numbers to divide the number line into 3 separate intervals. And then we pick a test point from each interval. In the interval on the left, I can pick any number that's less than 1/2. 0 is usually a nice number to pick for a test point. And if you replace every x with 0, we're just left with 3 is greater than or equal to 0. So that's true. So that means all of the numbers from negative infinity up to 1/2 are solutions. In the second interval, pick any number you want between 1/2 and 3. Picking 1 as a test point is often a nice choice. So if you replace every x with 1, 2 times 1 squared is just 2 minus 7 times 1. So 2 minus 7 is -5, and -5 plus 3 is -2. But the inequality, -2 greater than or equal to 0, is false. So none of the numbers from 1/2 to 3 are solutions. In the third interval, pick any number you want greater than 3. So I'll pick x to be 4. Okay, so this time there's a little more arithmetic involved. Replace every x with 4. So 2 times 4 squared is 2 times 16, and 2 times 16 is 32. And from that, we're subtracting 7 times 4, which is 28. And 32 minus 28 is 4. 4 plus 3 is 7. 7 greater than or equal to 0 is true. So yes, the numbers from 3 to infinity are solutions. And then the endpoints, both will be included because of the or equal to 0 part. Remember what 1/2 and 3 are. Those are the numbers that make 2x squared minus 7x plus 3 equal to 0, because those are the solutions to this equation. So 0 greater than or equal to 0 is true. It's the or equal to 0 that makes it true. So both of the endpoints are included. Put a bracket at 1/2 and shade to the left. Put a bracket at 3 and shade to the right. And then the interval notation, this part of the number line is parenthesis negative infinity, comma, 1/2 bracket, and then union symbol. This part of the number line is bracket 3, comma, infinity. That is the interval notation. And then the algebraic notation, x is in this interval. That means x is less than or equal to 1/2. And then we use the word or. X is in this interval, which means x is greater than or equal to 3. Okay, the next example, solve 3y to the second plus 8y is less than or equal to 3. Well, we want one side to be 0. That'll make it easier to find the endpoints. So we'll write 3y to the second plus 8y minus 3 is less than or equal to 0. Okay, so we're going to find the endpoints by solving the quadratic equation, 3y to the second plus 8y minus 3 equals 0. The solutions to this equation are the endpoints. So it turns out we could solve by factoring again, but let's just use the quadratic formula. So in this one, a is 3, b is 8, and c is -3. Okay, so y equals -8 plus and minus the square root of 8 to the second minus 4 times 3 times -3, all divided by 2 times 3. And then y equals -8 plus and minus the square root of some number divided by 6. 2 times 3 is 6. Okay, so inside the square root, 8 to the second is 64. And we're subtracting 4 times 3 times -3. So first, 4 times 3 is 12. 12 times -3 is -36. And so 64 minus -36 is the same as 64 plus 36. And 64 plus 36 is 100. So we have the square root of 100. That's kind of nice because 100 is a perfect square. So the two solutions, -8 plus and minus 10 divided by 6. Okay, up here I'll write the solutions separately. Since we need to know the solution separately, so we have the two different endpoints. Okay, the first one, -8 minus 10 is -18, and -18 divided by 6 is -3. So -3 is one of the endpoints. And then the other solution, -8 plus 10 is 2. 2 divided by 6 simplifies to 1/3. So 1/3 is the other endpoint. So we divide the number line into 3 separate intervals, plotting -3 and 1/3. -3 here and positive 1/3 there. 3 separate intervals to test. Okay, in the interval on the left, we can pick x to be, we're picking y to be -4. Okay, so in the inequality, replace every y with -4. You can use either of those two inequalities when testing. It works the same either way. You're just looking for a true or a false inequality. Okay, so how about if I'll just use the top one? If if y is -4, 3 times -4 squared, -4 squared is 16. 3 times 16 is 48. So I'll write 48. And then we're adding 8 times -4. 8 times -4 is -32. If we add -32, that's equivalent to subtracting 32. The inequality is less than or equal to 3. But 48 minus 32 is 16, and 16 less than or equal to 3 is false. Okay, so none of the numbers in that first interval on the left from -infinity to -3 are solutions. In the middle interval, 0 is in this interval, so that's what I'll pick for our test point. And then either of the inequalities can be used. If I use the top one, replace every y with 0, we get 0 less than or equal to 3. And that one is true. So the numbers between -3 and 1/3 are solutions. Then in the third interval, 1 is in this interval, so I'll pick y to be 1. Use either inequality. I'll use the top one again. Replace y with 1. 3 times 1 squared is 3, plus 8 times 1 is plus 8. 3 plus 8 is 11. And 11 less than or equal to 3, that's false. So none of the numbers greater than 1/3 are solutions. Once again, we include the endpoints. It works in either of those, but if you look at the one where it's less than or equal to 0, each of those two endpoints is what makes this left-hand side equal to 0, and 0 less than or equal to 0 is true. It's the or equal to 0 that makes it true. So we include the endpoints. Graphically, we put brackets at the endpoints, and then all of the numbers between those numbers, -3 and 1/3, are solutions. The interval notation for this is bracket -3, comma 1/3 bracket. The algebraic notation, so if y is a number in this interval, then -3 is less than or equal to y, and at the same time, y is less than or equal to 1/3. Okay, those two examples are fairly nice. We will see some other sorts of things that can happen. So the next example, solve y to the second minus 4y plus 20 is less than 0. Well, it's already in standard form. One side is 0. I'll just point out right from the start that any endpoints will not be included because it's not or equal to 0, it's just less than 0. Okay, but we want to find the endpoints. So we find the endpoints by solving quadratic equation, y squared minus 4y plus 20 equals 0. Okay, so let's use the quadratic formula. A is 1, B is -4, and C is 20. Okay, so y equals the negative of -4 plus and minus the square root of the number -4 squared minus 4 times 1 times 20. And this is all divided by 2 times 1. So we'll do the arithmetic. Y is equal to, the negative of -4 is +4, plus and minus the square root of some number divided by 2. Inside the square root, the number -4 squared is +16. And we're subtracting 4 times 1 times 20, we're subtracting 80. So the discriminant is negative. So we get y equals 4 plus and minus the square root of -64. Okay, we know how to simplify the square root of -64. But for this particular problem, we already have the information that we need. Since the solutions to the quadratic equation are non-real numbers, there are no endpoints to divide the number line into separate intervals. But we still have an interval to test. There's one interval to test from -infinity to +infinity. Any test point that I pick from that interval will represent everything else. So since 0 is in this interval, I'll just pick x to be 0. And then replace, in the inequality, replace y with 0. And we're left with 20 is less than 0. So that's false. So that means no solution, because we tested the interval. There's only one interval to test, and we got a false inequality. So that means no solution. In the Newton software, you would use the empty set notation. Okay, I'll just make a comment. If this inequality, I guess it was kind of hard for you to see, wasn't it? So let's see. We had one interval to test. I picked 0, got a false statement. So if this inequality had started out as greater than 0, we would have gotten a true statement for the entire interval. In that case, all real numbers would be solutions. And the interval notation for all real numbers is parenthesis negative infinity, comma, infinity, parenthesis. Okay, let's move on to the next example. Okay, down here on the left, x squared plus 10x minus 9 is greater than 2. Subtract 2 from both sides. Minus 11 is greater than 0. Okay, so we want to solve the equation x squared plus 10x minus 11 equals 0 to see if there are any endpoints. Okay, well this one, we can solve this one by factoring. One factor is x plus 11. The other factor is x minus 1. And when the coefficient of the trinomial is 1, it's easy to verify that the factors are correct. So you can just do this. You can multiply positive 11 times negative 1. That should equal negative 11, as indicated here. But when you add positive 11 to negative 1, you should get positive 10, which is what you see there. So that's a quick way to verify that the factors are correct. The quadratic equation has two solutions. One is negative 11. The other one is positive 1. So those two numbers will divide the number line into separate intervals. So I want to point out something here. Using this inequality with the left-hand side in factored form can be a convenient way to use test your test points. So this inequality is equivalent to this one because the left-hand side is just the factored form of that one. Okay, but our endpoints are negative 11 and positive 1. So we have 3 intervals to test. So on the left, in the interval from negative infinity to a negative 11, I'll pick x to be negative 12. And I'm going to use the factored form of the inequality. You don't have to. You can use any one of those inequalities. But if I replace this x with negative 12 plus 11 is negative 1. And in the other factor, replace x with negative 12. Negative 12 minus 1 is negative 13. The inequality is greater than 0. Negative 1 times negative 13 is 13. And 13 greater than 0 is true. So that means the numbers from negative infinity to negative 11 are solutions. In the second interval, we can pick x to be 0. So when x is 0, this inequality might be more easy to use. You can still use the factored form if you want. As long as you don't make mistakes with arithmetic, it really shouldn't matter. But this one, if you replace every x with 0, we're left with negative 11 is greater than 0, and that is false. So none of the numbers between negative 11 and 1 are solutions. And then in the third interval, we can pick x to be 2. And then the factored form might be more convenient again. So replace every x with 2. On the left factor, 2 plus 11 is 13. 2 minus 1 is 1. Greater than 0. This is obviously true. 13 times 1 is 13, and 13 greater than 0 is true. So all of the numbers from 1 to infinity are solutions. This time the endpoints are excluded because the inequality does not have the or equal to part. So graphically we put a parenthesis at the endpoints. So a parenthesis at negative 11 and shade to the left. A parenthesis at 1 and shade to the right. The interval notation for the solution, parenthesis, negative infinity, comma, negative 11, parenthesis. Then the union symbol, parenthesis, 1, comma, infinity. The algebraic notation, so this interval up here on the left means x is less than negative 11. Then we write the word or. If x is in this interval, it's x is greater than 1. Okay, we can do one more example, and then that'll probably be enough so that we can start the quiz. Okay, this one down here, x plus 2 times x plus 6 is greater than or equal to 21. We have some preliminary work to do before we'll be ready to find the endpoints. I suppose if you looked, you could probably eventually find the endpoints using this inequality. But I think it's going to be more straightforward if we multiply those two binomials, set one side equal to 0, and then solve a quadratic equation using the quadratic formula or some other valid method. So first we'll multiply x plus 2 times x plus 6, and we get x squared plus 6x plus 2x plus 12 is greater than or equal to 21. And then x squared plus 8x plus 12 is greater than or equal to 21. Then we'll subtract 21 from both sides, and we'll get x squared plus 8x. 12 minus 21 is negative 9, so we have minus 9 is greater than or equal to 0. Okay, so now we can find the endpoints by solving an equation. X squared plus 8x minus 9 is 0. And we can solve this by factoring. So why not solve by factoring? One factor is x plus 9. The other one is x minus 1. So if you want to go directly to factoring the left-hand side of the inequality, that's perfectly fine. You can still identify what the endpoints are. Since one side is 0 and the other side is factored, either from the equation or this inequality, either way, we can tell that the endpoints are x equals -9 and x equals 1. Okay, so we'll plot the numbers on the number line. -9 is to the left of 1, and we have 3 intervals to test. In the interval on the left, pick any number you want less than -9. I'll pick x to be -10. And you can use any one of the inequalities that you want. Even the original one is not too bad. So why don't we try that? The original inequality, replace every x with -10. So in the factor on the left, -10 plus 2 is -8. The next factor, -10 plus 6 is -4. And the inequality is greater than or equal to 21. -8 times -4 is positive 32, and 32 greater than or equal to 21 is true. So yes, all of the numbers from -infinity up to -9 are solutions. You can verify that the same test point gives you the same true result using any one of those other inequalities. In the second interval, 0 is in this interval, so let's pick x to be 0. Okay, use any one of the inequalities, even the original one. Okay, so let's use the original one again. Replace x with 0. 0 plus 2 is 2. 0 plus 6 is 6. So 2 times 6 greater than or equal to 21. 12 greater than or equal to 21. That's false. So none of the numbers in the middle interval are solutions. And then in the third interval, pick x to be any number greater than 1. I'll just pick 2. So this time, I'll use this inequality. So replace every x with 2. 2 plus 9 is 11. 2 minus 1 is 1. The inequality, 11 times 1 is greater than or equal to 0. Remember which inequality we're using. So this is obviously true. So all of the numbers greater than 1 are solutions. And we include the endpoints because of the or equal to 0 part. So this reminds us that the endpoints are what make the left-hand side 0, and 0 greater than or equal to 0 is true. So graphically, we put a bracket at each endpoint. And then this part of the number line is in interval notation, parenthesis, -infinity, comma, -9 bracket, and then union, and then bracket 1 comma infinity. And then the algebraic notation, x is less than or equal to -9. That corresponds to this part of the interval notation. The union symbol corresponds to the word or, and this one is x is greater than or equal to 1. Okay, we'll stop there and we can start the quiz. I'll go to my office and email you the quiz.